In this example, we're going to take a look at graphing a line using x and y intercepts. We're going to calculate the x-intercept and the y-intercept, graph the line, and then we'll check to determine whether or not we've done the math correctly. The form ax plus by equals c is known as the intercept form of an equation. When we see an equation in this form, we can easily use it to find both the x-intercept and the y-intercept to get two known points that are on the line. We're going to graph the equation 2x plus 3y equals 6 by finding the x and the y-intercepts. We can find the x-intercept by substituting 0 for y in the given equation and then solving for x. Here's our equation, 3x plus 2y equals 6. We know half of the ordered pair for any point that is on the x-axis. Any point that is on this axis has a y-axis value of 0. Since it doesn't move off the x-axis line itself, it doesn't move in either positive or negative directions, so it's always 0. So we know half of the ordered pair already. And since we know that half, it's very easy to calculate the other half. So here we have 3x plus 2y equals 6. Notice the variable x is in red. That's the one we're going to solve for. And now we're going to remove y and we're going to substitute 0 into the equation. And then we'll simplify. So 3x remains there. 2 times 0 is 0. And so we have 3x plus 0 equals 6. Simplifying one more step, we get 3x equals 6. We need to clear the coefficient that's here, and so we'll have to divide both sides of the equation by the same number to clear that coefficient. So we're dividing both sides by 3. Same number, same sign. 3 divided by 3 is going to give us 1x, or simply x. And now on the right side, 6 divided by 3 is going to give us 2. So now we know the ordered pair for the x-intercept, and we can go ahead and graph that on our Cartesian coordinate system. Next, we'll take a look at finding the y-intercept. We do that by substituting 0 for x in the given equation and then solving for y. So here's our equation, 3x plus 2y equals 6. Again, we know half of the ordered pair. Any point that is on this y-axis will always have an x-axis value of 0. So we know half of the answer already. We'll go ahead and finish now by calculating the remaining variable. Notice now that y is the variable that is colored. This is because we're going to solve for y. We know that x is equal to 0, so we remove x from the equation and plug 0 in instead. So 3 times 0 is 0 plus 2y equals 6. Simplifying one more step, we get 2y equals 6. And now we need to clear the coefficient that's here. That means we're going to divide both sides by the same number, and that's 2. So now on the left side, 2 divided by 2 is 1y, or simply y. And on the right side, 6 divided by 2 is 3. So now we know the ordered pair for the location of the y-intercept. It's at 0 and 3. So it's going to be located here on the y-axis. The next thing we need to do is draw the graph line. When you're doing this, you want to make sure that you take your time and line the intersection of those points up very well before you draw your line. Drawing it accurately will help us in this next step where we're going to check to see whether or not we've done this math correctly and gotten our intercepts recorded. We can check the line by locating a point other than the intercepts that is on the line and finding its ordered pair. Any point that is on the line is a solution to the equation. Once we know the ordered pair of a location of a point other than the intercepts, we can substitute it back into the original equation to see if it produces a true statement. Here's what that's going to look like. You want to look for a point that's located at the intersection of grid lines because those will give you numbers that will be easier to work with. We look for a point on the line between the intercepts first. This is generally the most accurately drawn component of the line itself. If you can't find one there, then you'll have to look on either end of the graph line. You might find lots of points or just a few. We can find 2 points for this equation that can be used to check the line. On this end of the line, we see the intersection here is a point that we might possibly be able to use. And on the other end of a line, we can find another point that could possibly be used as well. We need to find the ordered pair of one of those points. It doesn't make any difference which point you choose, since every point that is on the line is a solution to the equation. We're going to use this point. And if we write the ordered pair from origin, we are in the x-axis over 4, and in the y-axis down a -3. So we're going to use 4 and -3 to check the line. We go back to our original equation, which was 3x plus 2y equals 6. And now what we're going to do is we're going to remove x and plug in 4, and remove y and plug in -3. And then we'll simplify the left side of the line. 3 times 4 is 12, plus 2 times the -3 is a -6, should be equivalent to 6. 12 minus 6 is going to give us 6, and so it checks. That tells us that we've drawn the line correctly and that we have our intercepts calculated correctly as well.